biophotonic scanner, gene expression work that has led to some personal care and some nutrition products that are outstanding, right? And then lately, ageLOC Me and ageLOC LumiSpa. Very hard to top, isn't it? But we are continuing forward on this role of innovation. And so today we want to learn about something that affects all of us, and that is water. Is there anything really, besides food I suppose, that is more essential to your life? And it's something that we consume every day, and it's something that we don't want to take for granted. And pure, clean water on this earth is actually sort of a rare thing. You get pretty good water quality here in Singapore, right?
Yes.
How many of you still boil the water that comes out of the tap? Yeah, a lot of you. Now, why is that? Perhaps you don't absolutely, completely trust that the water is pure. I'm going to share with you some things tonight that hopefully will teach you about water, and will also teach you about water filtration, and even some really sticky, weird topics like alkali water and things like that. So, we can't all drink straight from the stream like this beautiful lady. And in fact, water, we're not quite sure where it comes from, right? I think your water comes from Malaysia. I don't know what it starts looking like, but the idea is that we need to have it pure and clean. And the solution often is like either to boil your water after it comes out of the tap already, or what a lot of people are doing, right, is drinking out of these water bottles that we also hope we can trust, right? And there are some side effects. And that we need to start thinking about, right? The impact that it has on our environment. Where does all that plastic go? Should we really be cutting down on that a little bit? Maybe Nu Skin needs to make a special water bottle, I don't know. But it takes a lot of effort and a lot of social responsibility to think about our packaging and to start keeping the earth a little cleaner. So, as we mentioned earlier, a lot of you are still boiling the water. Now, does boiling the water really solve all the problems? What does boiling the water do? It makes it hot, and if you cool it down, right? So, presumably, then you are killing all of the bacteria, right? Bacteria, viruses, whatever. Is there anything else that might be in the water that boiling is not really helping? In fact, when you boil the water, you're sort of concentrating a little bit. So if there's heavy metals, or if there's other things, pharmaceuticals or insecticides, you're not going to change that by boiling it, right? So there's things in the water that you necessarily can't see that maybe there's a better solution than just boiling it. And hopefully we can offer that today. And a really good home filter, I think, is a great solution. So when we were asked to do this by the Southeast Asian marketing team about 3 years ago, we said, well, we've already been looking at some of this technology, but I put my best team on it. So some of my brightest young scientists are the guys that actually developed the biophotonic scanner. So that was the team that helped us develop this, right? So the first question was, what are the makings of the inside of a good water purification system, right? What's on the inside? And so at this point, you know, it's really, that's where it starts. It's not really about how it looks, right? It's how it works. So I liken this to when we were looking for our spouse, when we were looking for someone to marry. What was the most important thing? Was it the beauty on the outside, or was it the intelligence and the personality on the inside? You know, that's what I like about Nu Skin, because most audiences would say one or the other. But Nu Skin people know that you can have both. Why settle for less, right? We can have both. So our journey then began looking, building it from the inside out, going around the world, going to all of the trade shows, finding out what is the latest technology in water filtration. And this isn't something that's a brand new technology, but incremental improvements are being made over time. And we can and we did learn what are the best technologies. And what order should those technologies be in? Okay, what kind of filtration medium would be the best to use? There are certainly many choices. We learned about carbon, and that not all carbons are alike. In fact, that these you can have activated carbon that has amazing qualities. But should you have that in a block, or maybe in a granular form? We learned about other filtration media, pleated filters made of different substances, of different weaves and tightnesses and tolerances. Right? We learned about what kind of effect would this have on our health. You know, how good are those media? Are they going to slow down the water flow? Do we need to have water that is wasted in order to achieve water filtration. So all of these questions we were able to ask questions around the world. And this is a journey that took at least 2 years of homework. And then after we were asked by Southeast Asia to develop this filter, then we worked on it for quite a long time afterwards. We needed to find out all the answers, what the best technologies were. And so today we're going to talk more about those. So after we'd learned those things and we pretty much decided the best media, what to use, then our focus turned to what the device is going to look like. It doesn't look like this. And this is exactly what we didn't want it to look like, right? We didn't want you to have an engineering degree to install a water filter, right? And so we started then, this was the fun part, I had a Nu Skin credit card, part of my R&D budget. So I started to then order water filtration systems from around the world, some expensive ones, some cheap ones, to see what's the user experience like, what are these devices like that are on the market, what do they look like, how do they feel, how does the company treat you? And so this is actually a very common theme. We would find inside a box lots of this white tubing of varying lengths. We would find these weird and wonderful connectors that may or may not sort of go with your kitchen decor, right? Washers and things, and after assembling them, it's amazing how many times 1 or 2 of these were left over, and we weren't sure if it was going to leak, right? Other things, like when we finally got these things assembled, and we have some smart guys in the lab, and it still took some time. This is stuff that's designed to be easy for you to do yourself. Here's an example of one that had 3 different filtration units that all needed to be connected. And everywhere they're connected, a potential leak, right? And I'm not a plumber, but it's not always easy. Then came time to replace the filter. How easy is that? Because when you buy a filter, you need to replace those filters frequently. And so how easy is it to do? And in this case, we had to undo 6 connectors and then try to put the filters back in the right order and rewire the whole thing and then sort of pry the lid back on. And I'm sure that there are many of these types of things where you change the filter once and then you just say, I'm not going to go near that thing again. You know, how long has that filter been there? Well, I changed it about 10 years ago, but I haven't been game to go near it, right? Is it filtering your water? Well, I'm really not sure, but I'm not going to go near it again, right? Here's an example of a box that arrived, and this is kind of, unfortunately, very typical. How good is this user experience? Where there are tubes and things hanging out, things aren't labeled, not very easy, right? We don't want that for a user experience. Size matters in the kitchen, doesn't it? How many of you have large and spacious kitchens? No, I didn't see any hands go up. It's kind of typical around the world. It's not a place that is spacious. We can't afford to have huge kitchens. And so bench counter space is very important. You don't want something that has a huge footprint. And you also don't want it to look quite like this, right? We want it to look classy because we're proud of the places that we live. We want it to look nice. We don't want it to look like someone is rebuilding the motorcycle engine on your kitchen bench, right? Yeah, my dad did that one time, and I remember how angry my mother was, so don't do that. And don't have a water filter that looks ugly. We need one that looks nice. Now, I've got a few minutes to deal with the topic. How many of you have heard of alkali water? So some filters you all have, right? Some filters are offering this for their customers, and they say, you know, there's a health benefit to alkali water. What's the answer to that? Now, I could stand here and tell you there's no science behind it, let's move on. But how many of you are going to be convinced of that, right? Because you have friends that are saying, no, wait. It's all over the internet. I've read about how alkali water and even alkali diets can impact your health, give you more energy, help you lose weight, right? Even prevent serious diseases. And the cancer word comes up a lot. And that starts to scare people, and they say, well, is there science to that? Is that something that our ancestors didn't know that suddenly we know about now? So let me clear that up a little bit for you. Do you mind if we have a little bit of a chemistry lesson?
Yes.
All right. So I'm going to ask some questions. First of all, you know what acid is, right? Acid. So I'm going to write acid up here. Hope you can all see that. And then on the other end of the scale, if it's not acid, the opposite of acid is alkali, right? So down here. And how do you measure acid and alkali or base? pH. Beautiful. All right, so pH is used to measure little p, big H. Anyone know what that stands for? pH? What it is? Here's where the fun part comes in. pH equals the negative log of the hydrogen ion concentration. Okay, everyone laughs when I write that down, but it's really not that difficult. I'll help you to understand exactly what this means. Hydrogen ion, right? You know water is H2O, right?
Yes.
So you've got H, H, and O, right? And they actually can separate out so that you can have hydroxide ions and hydrogen ions, right? So they kind of always go back and forth a little bit. These little guys are acid. So if there's a lot of hydrogen ions in there, then your water is acid. Or if there's a lot of hydroxide ions, your water is basic, right? That's clear, right? Not too hard. So, the concentration of these guys, the hydrogen ions, tells you the acidity. So I'm going to talk now about the scale, right? So the acid-base scale of pH, what's the most acid? 1. And it goes all the way down to basic, which is?
14.
14. So let's have really acid is a 1. And then it's going to get less acid until you get, where do I stop?
14.
Where's neutral? Where?
7.
All right, 7 is neutral. Okay? So this is pretty easy to understand. And then 8, you're starting to get alkali all the way down to 14, right? So there's your acid scale on a pH. Now, how many of you know how much acid is in your stomach? What's the pH? Yeah, pH is right around here somewhere, right? Now, okay, so you know we're talking about the concentration of hydrogen ions, and it gets stronger as you get towards 1. That's where the negative comes in, right? Now, what's the log mean? Log means logarithmic scale. Don't look at me like that, it's not that hard. It's not hard. I've got people here going, I failed chemistry in high school, I don't want to do this again, right? It's pretty easy. Okay, so we don't have earthquakes in Singapore very often, right? But I want to ask you a question. On the Richter scale, you can feel a 4 on the Richter scale, earthquake, right? A 4. You know what I mean? 4 on the Richter scale? There was an earthquake in Bali this weekend. It was 4 on the Richter scale. Right? You know, it's like, okay, people felt that, but it wasn't bad. The question is, a 5. A 5 on the Richter scale is exactly how many times more powerful than a 4? Anyone know? That's where this thing comes in, the log. A log is like a 10-fold difference, right? So a 5 is exactly 10 times more powerful than a 4 on the Richter scale. So then what's a 6? It's 100 times more powerful than a 4. And so on, right? That's a logarithmic scale. That means every number represents a 10-fold increase, all right? So pH is a logarithmic scale. That's what it means, the negative log of the hydrogen ion concentration. Now it's getting easy, right? So if the pH at neutral, let's say there are 10 hydrogen ions in your water normally, right? 10 hydrogen ions. Then 6 is going to have how many? 100. And then 5 is going to have 1,000. And 4 is going to have 10,000. All the way up to 1, which is, are you quick? How many hydrogen ions in a 1? 1 million hydrogen ions, right? So let's say that's your tummy. This is your tummy here. Here's the tube that comes down from your mouth. Here's your tummy, your intestines, right? And your tummy has a concentration of 1 or 2 pH, right? So you've got like 1 million hydrogen ions in here, let's say. Now, someone says, alkali water is really going to make a difference to your health. You've got a glass of alkali water, right? And in that glass of alkali water, which is a little bit lower than 7, you might have a couple of hydroxide ions there, right? Now, when you add 1 or 2 hydroxide ions to 1 million hydrogen ions, is it going to make any difference at all? No. No, not at all. I mean, do you suddenly curl up and die every time you have an orange juice? Because that's got a pH of like 3. Right, so just looking at the numbers and the chemistry, alkali water, alkali diet cannot impact your human metabolism at all. But let's just go a little bit further. You know that your body has this thing called homeostasis. That means your body can always try to stay sort of in the middle. So when you get hot, what happens?
Perspire.
Yeah, before you even perspire, you feel hot. You go, I'm feeling hot, I'm going to take my coat off. Because your brain says you're hot and you don't want to be hot. And you say, it's getting hotter, I'm going to take my shirt off. But wait, I'm in public, I'm not going to take my shirt off. So then I start to perspire, right? And the perspiration evaporates and cools your skin. That's called homeostasis. The body also guards very closely the pH of the body. And it keeps it at pH 7.4. 7.4 is your body's pH. The tissue and the blood do not deviate from pH 7.4. So you may go on a crazy alkali diet. You may even bypass the water and just drink bicarbonate of soda. It is not going to change. It's not going to impact the pH in your gut, and it's certainly not going to impact the pH in your body. Does that make sense?
Yes.
All right. Now, I've got a few more minutes. Where on earth did this story come from then? Why are people talking about this? Well, it turns out this is where I think, from all of my reading, I think this is where it began. Scientists grow in test tubes, or basically in petri dishes. They can grow cells. So usually these cells that they grow in petri dishes are cancer cells, because cancer cells live forever and for many generations. So here are some cancer cells growing in a petri dish, and we always keep it about pH 7.4, and they're very happy. And then some scientists discovered that if you somehow make a mistake and it becomes more acidic in there, maybe it goes to 7 or 6.8, then these cancer cells are a little bit happier. They grow a little bit faster. And so someone sort of got a hold of that research and said, that means if your body is getting acid, you're going to get cancer. It's not true. Your body acid, like I just said, doesn't change. Okay, so I think we're being scammed by this. It's fake science. It's fake news, all right? So, do you think that puts it to rest now?
Yeah.
Okay, if there's a company that makes a water filter that touts the health benefits of alkali, then I actually, because that's not real science, don't even trust the ability of that company to make a decent water filter. We need to stay science-based, folks, right? All right, let's move on then. I'm glad we got that out of the way. Maybe that gives you some of the history, some of the science. You can help explain it to your friends. But if you can't explain it, just ignore it when they try to talk about other things. All right? Okay, so let's get on with the filter then. We really started to design now what it looks like and what's inside. And so we had a list of criteria after all of our research of what we needed to be. We needed to be intelligent ultrafiltration. Okay, we want it to be so good that the people in Singapore are convinced that they no longer need to boil the water after they've got it out of the faucet. Okay? Fast installation, because that's really important user experience, isn't it? Easy filter replacement. We don't want to have the triple filters with the 6 connectors, right? We want elegant design, because you're proud of your kitchen. You don't buy ugly things for your kitchen, and you certainly don't rebuild motorcycle engines in there. Small footprint, right? Because of space, a closed system, and we also consider it to be very important that you can have good water filtration without wasting a lot of water. For example, reverse osmosis is very good water filtration. It's a good technology, but most people don't realize the dirty little secret that for every liter that you filter, somewhere between 2 and 5 liters are wasted, go down the drain. It's part of how you use water to clean the water. So that was a consideration. We didn't want wastewater, and we wanted a great user experience. And this is what we created then. You've already seen it, the beautiful and sleek Ecosphere water purifier that looks just great in any kitchen. We don't have, you notice, we don't have a whole bunch of wires or tubes leading to the diverter there, just one. And I'll show you later how beautiful that diverter is as well. So it's an exclusive design. This is something that we had to design ourselves then from the inside out, because nobody else was offering something with the user experience and the beauty and the functionality and the perfection in ultra purification that we wanted. So this was designed from the ground up by us. Here's the top, Alexan top.